Okay, now this is another example with centroid, and this time, instead of giving you a piece, they've given you this whole little bit. So what we have going on here is the whole thing from M to R is 69. But do remember that it's twice as far from the centroid, the center to the corner, as it is to the edge. That means even though we don't know this value, if I can call this one x, this one's twice as far, which is 2x. And now I have a little equation I can set up that 69, the whole thing has to be equal to 2x plus x. So that means 69 is equal to 3x, and x is 23. Once I have x is 23, I can find whatever I need. So in this case, they wanted you to find MT. So if TR is 23, it's twice as far to the corner, so that would be 46. And you could always check by saying, is 46 plus 23 really equal to 69? And it is. But this little logic here where you say, hey, I don't know either one, so I'm going to call this one x and this one 2x, since I know it's twice as much, using that will help you on a lot of geometry problems. We'll try a couple more examples with quadrilaterals now. Okay, quadrilaterals, it's true that the angles that are opposite from each other are equal. So this is 20 degrees, and this over here is also 20 degrees. And this is x, and this is x. So one way you can do this is you could add up 20 plus x plus x is equal to 360. So that's 40 plus 2x is 360. And then you subtract 40 from both sides, so x is 320, and then x equals 160. Now at this point you might say, was there an easier way to do that? Well, actually there is. The angles that are adjacent to each other, and by adjacent I mean beside each other, they're on the same side of the triangle Q and R. These adjacent angles I always do add to 180. So I could have saved myself some time by doing x plus 20 equals 180. And that would have given me 160. Or I could do it the longer way using the fact that the opposite angles in a parallelogram are equal. So hopefully this will help you solve these type of problems. Let's look at another example. Okay, these angles are adjacent to each other. You can tell because they share the same side of the parallelogram. So if I have x plus 70 should be equal to 180, and then just subtract 70 from both sides and get 110. If you wanted to check that, you could say, hey, this is also 70 because opposites are equal. In a parallelogram, if this is 110, this is 110. Check and make sure they add to 360. It will. But you don't have to do that. You can just do it this way, and you'll be right done with the answer. Let's look at one more type. Okay, another thing that's true of a parallelogram is their diagonals bisect each other or cut each other in half. So if this part of the diagonal, EH is 23, then the other part of that diagonal is equal. When parallelograms, their diagonals intersect, they bisect each other, meaning they cut in half. So this is also 23. Let's go ahead and look at another example. Okay, on this one, basically, they're telling us NQ all the way across from N to Q is 32. And they want us to find NS, which is just partway across. Well, remember we just said that they bisect each other. So whatever this is the same thing. So it's true that I have x plus x should be equal to 32. So 2x is 32, and x is 16. Some of y'all might have just could have looked at that without the equation, said, hey, if the whole thing's 32 and it bisects, half of it's 16, that's another way to get there. Whether you write the equation or not, you just need to be able to get the correct answer. Let's try maybe one more. Okay, on this one, they tell you QR is 19. So if this is 19 and they bisect each other, this is also 19. So that's what it was looking for. Just in case, if they would have asked you for NQ, once you know that both halves are 19, you could have added them together and just said the whole thing NQ would be 38. So be careful what they're asking for, but these parallelograms, their diagonals just bisect or cut each other in half. There's no guarantee now that RQ would be equal to one of these other halves of a diagonal, but it does have to equal the other half of the same diagonal.